Hi Professor, this is my fellow presentation and my topic is Adapt's study of Docker performance. First, I will talk about the problem statement. So why we need to explore the Docker performance? I think is because everyone are concerned about the resource sharing in the cloud. Currently, cluster managers from both the academia and industry are following the trend of resource isolation. For example, network is very important. If we just have 10 gigabytes per second bandwidth in the cluster, and every virtual machine need 2 gigabytes per second at some time. If we need to hold hundreds of virtual machines and they all need that much resources at the same time, how we protect our resources and how we guarantee the whole system won't crash is a huge problem. And compared with the virtual machine, the problem with containers are worse because container is super lightweight and a cluster load can hold thousands of containers together. If there has a small problem between containers, then when it runs thousands on the cluster, it will be a huge problem. It may produce problem of network I/O bandwidth, or it may compute disk I/O problem. So we also need to think about scalability problem. Then let me talk about the proposed research. So we need to compare the Docker with KVM, and then the first one is full virtualization and the second one is peri-virtualization. And why I think what I did are different from each other is that because for the pressure scenario part, which produce significant poor performance, we increase the performance impact to get the performance bottleneck. And why I think the performance of bottleneck, I will explain to you later. And when the long obvious particular issues that affect virtualization to handle specific complex scenario. So I think our work are meaningful. Then let me start with network I/O isolation exploration first. Let me start from the result I got before the midterm. I have some stress test which shows here. So if I run the stress test, the first one, then I will get the purple result. If I run the second one, I will get the blue result. But as we can see that only Docker have that kind of bad isolation result. KVM and Zen has very lower degradation. Degradation means the how worse it compare with the baseline. So the higher degradation is the worse the results are. Then let me talk about the TC control tool, which I use to control the network bandwidth for Docker containers. How is that? Because I get the average network bandwidth for the stress test are 2.7 gigabytes. So I set the network bandwidth limitation as 100 megabytes per second for the Docker containers. And these Docker containers are only the stress test Docker container. To be specific, I use the steps as follow. The main idea is that I set priority and how many max that I can use for the whole class and how many I can use for one child class. Then I will show you the result that after TC control. After TC control, we can say that all these results have a obvious degradation reduce, because this figure is to show the degradation reduce. So which means the higher the results are, the better the TC control tool is. As we can see, PCDS will have the highest network degradation reduce. Based on our analysis, actually the result I showed before is from the 3-load Hadoop reduce. I want to implement the Hadoop distribute system in a normal size. I want to increase the data load to 20 and increase the stress test load to 6. I have already implemented it in the cluster. Then I want to separate the data loads into 2 different hosts, which I think we discussed that before, and I have implemented that locally already. I will set some cases to test them. The first one is that I move the half of loads into another host. Then I left only the first load have the stress test, and the stress test number is 6. Then I will set both of the hosts have 3 stressed containers. So finally, I will do that both hosts have 6 stress containers. We will get some rules, simple rules from the result, because if the stress test impact linearly, it's like the more the stress test impact is, the higher degradation is. We can get that from the result, but actually what I get from my result cannot prove that. It shows all the stress tests will have a bottleneck, which means the container will at least guarantee some resource under the extremely competition environment. So at first, let me show you how my containers communicate with each other between the different hosts. At first, you know the containers all need to talk about the Docker 0 bridge, then talk about the ETH0. Then the ETH0 will communicate with each other. It will be like the picture shows. As we can see, if the container in the right want to send the message to the container in the left, it will go through like that. Container right to the Docker 0 bridge right, and to the ETH0 in the right, and to the ETH0 in the left, then to the Docker 0 in the left. Finally, it will go to the container in the left. Then let me talk about the Hadoop Terraform itself. What we use for this experiment is because Hadoop is a real-world benchmark and is very CPU intensive and IO intensive. If one benchmark is not CPU or IO intensive, we don't need to test it, because we want to get the isolation of different containers. If it's not resource computation intensive enough, we won't know how good the isolation is, because everyone doesn't run out of its own resources. It don't need to borrow any resources from others. Then let's talk about the experiment 1. I have 20 loads with 6 stress tests that are separate. And I have already implemented that in the cluster. As we can see that the bigger picture is from the 20 loads and the smaller picture is from the 3 loads. As we can see here, when we implement 20 loads, the degradation before the TC control will be much higher than the 3 loads, which means 3 loads are not CPU or IO intensive enough. It's not intensive enough. But after the TC control, we can see all the degradation are controlled under 4, which means TC control with the specific parameter have a very good isolation control to the Docker containers in the cloud. Then let's talk about this experiment 2. I have implemented it locally. The first picture shows the same setting with the cluster. As we can see, the network transmission will up to 20 and is very high. And the second one shows a case that we move half data loads to another host, and only one host has 6 containers compared with the first one. We can see that the second one has much lower degradation. And what is the reason? The reason is, based on my own understanding, is because when some of the stress tests be very intensive, then the containers, the Docker loads in the same host will be super slow. And when the Hadoop detects the super slow loads, it will assign some works to the lighter slows, which will make the whole Hadoop running much faster. This is the reason. And let me talk about the figure 3. The figure 3 shows a case that both the hosts have 3 stress containers. If the stress test impact are linearly, then we should say that the figure 2 and figure 3 has the same result, because in total they all have 6 stress tests, right? So, but the results are different. The figure 2 shows much lower degradation than the data 3. And for the figure 4, it shows the case both hosts have 6 stress tests. The results are very similar to the figure 1, which means that maybe 6 stress tests for 10 containers are very intensive enough. Then based on the analysis, we can get conclusion for this part. First, the impact of the stress test is not linear, and which means it has bottleneck. So I think it means the container can still guarantee some resource under extreme resource competition. The second one is, the TC tool is really a good tool for us to protect the specific container's resource, but it has obvious limitation. We need to set priority to different containers at first, which means they're not equal, because they always have some containers that have lower priority than you. Also, because what I set for the Docker container, the limitation is just 1 megabytes per second, which is super small. We cannot protect containers from each other that well in real-world practice. So finally, let me talk about the scalability exploration. I have finished the experiment of scale up and scale out. And for the scale up experiment, to measure the ability of 3 different virtualization technologies, we first compiled Apache source code through one thread and set the runtime at baseline. Then we increased the number of threads that running an Apache compile experiment. In the following section, the ratio of runtime over baseline will be calculated like that. As we can see that Zeng has the best scale up performance. The reason I think is because the thing is not very heavy and it don't have the fully virtualization, so it's still very flexible. But compared with the Docker, because the Docker depends too much on the host kernel. So when one container run too much thread, it leads to communicate with the kernel too frequently, which also costs time. Finally, let me talk about the scale out experiment. As we can see here, the Docker has the best scale out performance, and the KVM seems cannot hold 128 machines in one load. The reason is like, at first, Docker is very lightweight, and if there is just one Apache compile in one machine, the Docker don't need to talk with the kernel too much, then it will save time. Also, because Docker don't need too much resources overlap when it do the Apache compile, so it won't affect their performance that much. Based on the 2 experiments, I got some assumption. First, the Docker's isolation of disk and network I/O is not good, but it still can have the good scalability performance. The reasons may be like below. As we all know, the Docker CPU isolation is good, and these benchmarks are more CPU intensive. The second one is because the benchmark don't need too much FIO. I have already did the experiment. The Hadoop Terraform benchmark will have the 4 to 5 times of the disk I/O bandwidth than the Apache compile. So even the Docker don't have a very good disk I/O isolation, it won't affect the final scalability performance. The third assumption is that because this benchmark don't network bandwidth intensive, because it don't need to communicate with each other that much, right? It don't like the Hadoop Terraform. So my plan is that I want to try some mini applications using Docker container and make them disk and network I/O intensive enough. Then we can see with the disk and network I/O intensive, the the Docker container can still guarantee some specific small resources to their own a lot. Finally, thank you for watching. This is my final presentation. Thank you so much.